Hey everyone, today we are going to be talking about the new ONNX release, version 1.13. And I am joined by Prashamik here, who was the PM for the release, and he is going to tell us a little bit about what is in it. So, first, why don't you introduce yourself?
Hi, I'm Wysocki. I am an AI frameworks engineer. I work at Intel, and I am contributing to ONNX on behalf of Intel. Mm, the release contains a lot of new features and bug fixes, which we're going to talk about very briefly here. The release includes quite a few new operators. One of them is column to image, useful when applying convolution filters to images, and also quite a few bitwise operations. Also, not only are there new operators, there are also quite a few operator extensions, which some of them are resize, which gets quite a few new attributes. Also, there's a pad which includes new attribute access. There are a few optional has element and get element changes. There is also new reduction attributes in scatter element and scatter ND. Also, there are some changes to split. ONNX now supports uneven tensor splitting, and there is also a new num outputs attribute. So now split is not dependent on the number of outputs of a tensor. And also there is a new version of LP pool, which includes new attributes, which are sale mode and dilations. Besides that, there are three new functions. One of them is center crop pad, which basically combines padding and cropping, so the tensor you give is the same size regardless if the input tensor is smaller or bigger. There's also mesh, which is an activation function used, for example, in the YOLO network, and also a new group normalization. Besides that, quite a big feature of this release is the reference Python runtime, which is the Python and NumPy, so it's very, very bare. And it is used to run our backend tests. So now you can actually run them with ONNX itself and see how they work and what outputs they return. And also you can see how the operators are implemented in the code. Also, Python 3.11 support has been added, which is quite important because Python 3.11 is currently quite known for the performance boost it gives, which is quite important for, of course, the AI and machine learning applications. Also, there is support for Apple Silicon, the new M1 and M2 processors. It is new. And besides that, of course, ONNX comes with very numerous bug fixes, feature improvements, CI improvements, documentation updates, and security updates. The list of them is quite long, so it's available under the link that is in the release notes. I encourage you to take a look at it, and the list of contributors who took part in providing the new release.
Awesome. Well, thank you so much to all the contributors. Thank you for that great overview. Now, stay tuned because we are going to jump into some more details on some of the features that he talked about. Thanks so much for joining me.
Thank you.
Next up, we have Xavier. He worked on another feature within this release. Xavier, why don't you tell us who you are, what you do, and what you worked on?
So I'm Xavier Dupre. I'm working on ONNX, and I work on many packages related to ONNX, and I've been doing that for 5 years now. And we're going to talk about a feature I recently introduced in ONNX, which is called reference implementation.
And why was this feature created?
I've been doing many things on ONNX, and the first thing I did was writing converters for scikit-learn. So my goal was just to write pieces of code, taking a model coming from scikit-learn, trained with scikit-learn, and I had to convert it into ONNX. And while doing that, I was always playing with big models and trying to see what ONNX was doing and what scikit-learn was doing, and trying to check step by step where my conversion went wrong. And while doing that, I had to develop a tool to see the evaluation of my model step by step. And I just gathered all the pieces of code into something I could share.
Do you have a demo that you could show us?
I have. So a
Awesome.
quick demo. Let me share my screen. So the reference implementation I did was just to first evaluate a model, but this is not the only way to do it. And I could evaluate a model step by step. So I'm going to show you that. And after, I'll just end the demo by how to evaluate a custom node, a custom operator you would like to introduce to ONNX, but it's not existing yet. So first, just a very long piece of code I took from a tutorial, and I just going to execute this code to have a very simple ONNX model. So it's just doing a linear regression, matrix multiplication, and then followed by an addition. And when I want to evaluate this model step by step, I just use the class introduced called reference evaluator. I fill that with the inputs, and I just run, and you get the input. And you can increase the verbosity of this runtime, and you get more information. So you see it went through matrix multiplication, generated a result called XA, and so on. And if I increase again the verbosity, you get more information. So you get, for example, the type of every input, their shape, and a range for the coefficient. And you can go and get more. So that's it for the evaluation step by step. And I use that a lot to check where my model went wrong compared to the scikit-learn model. So that's one feature.
Looks like a great debugging tool to really dive into what's happening and try to figure out, how your model's actually working.
And something I used a couple of times too, it was to check if we would like to introduce a new operator in ONNX. So this is just a very simple operator, a dummy one. We don't need that, but just it's very simple. So and it's doing a couple of operation, and I'd like to evaluate a model using that node. So I took the code you didn't see, but I just added one line with this new node, and I get a new model with this new node. And now, if I want to evaluate that model, I just have to somehow register that new implementation by adding this to my previous code. And it will run. And you can see in the results, you see this node is part of the evaluation now. So that's, I would say, the main two features this new feature introduced.
Thank you so much for that awesome demo. Where can people go to learn more?
The ONNX documentation now contains a tutorial you can follow if you want to discover ONNX. And the example I took is coming from it. And inside that documentation, you will find a full description of the API, including the reference evaluator I just showed you.
Great. So I am sharing those links here. They'll also be in the description. Thanks so much for hanging out with us today. All right. Next up, we are joined by Jacky Chen. Thank you so much for being here. Why don't you tell us a little about who you are and what you worked on?
Yeah, thank you, Cassie, for having me. So yeah, this is Jacky Chen, and I have worked at Microsoft for 3 years, and I have worked in like ONNX runtime all the time, and I focus on ONNX infra. So today I'll give you some exciting updates for the latest ONNX 1.13 release.
Awesome. So I know you worked on the Python 3.11 support. Can you tell us a little bit about what are some of the benefits of supporting that and why it was important for us to add that support?
Because the Python 3.11 is much faster than previous Python versions, and we do see there are a lot of ONNX users are asking about this 3.11 support. So finally, we decided to add Python 3. Will support in ONNX in advance, so ONNX users will benefit from it.
Great. It's nice to see things that, our community is really wanting and needing and being able to deliver that in this release. And another thing that it was delivered in this release was the Mac support for M1 and M2.
Yeah. So for that one, we add the M1 and M2 will support, and thanks and external contributors outside from Microsoft, Chen, he add this pipeline support in the CI. So going forward, like in ONNX, for if there's a M1 M2 users, they want to use ONNX, they don't need to build ONNX from source. They can just simply to download them from PyPy, and very easy to use ONNX.
That is great. That is super useful because I know that setting up and building ONNX locally, although we have great documentation on how to do that, it can be a time-consuming step. So that's a great way to support our users and make those available through PyPy. All right. Well, thank you so much for joining me and talking about some of these great features that were work done by you in the community. I love seeing our community get in and help out and contribute to the open source project as well. So thanks again. Okay, next up, we are going to talk to Natalie. She did some really great improvements to the documentation for ONNX. Welcome. Why don't you tell us a little about yourself?
Yeah, hi there, Cassie. I'm a PM on the AI frameworks team, and the thing we're talking about today is a hackathon project that I participated in Microsoft's recent hackathon, and
Awesome.
that was to improve the ONNX documents.
Okay, great. Let's jump in and take a look at some of these awesome docs updates.
Yeah, sure. You can see on the screen we have 3 sections in the documentation web pages, and the first is an intro, and that runs through ONNX concepts and how you would get an overview of the data types and how ONNX really works. There's also a section on how to use the ONNX Python API, and then how to take a model for source format and convert it into ONNX. This section here, the API reference, that is for people who are creating graphs and models directly in ONNX, and this is a Python API, and there's a detailed specification of how to do that in there. And then our final section, which is the bulk of this documentation, are detailed operator specs, and this would be used by ONNX implementers, spec implementers. And there's a lot of functionality here. So for each operator, we have the operator spec, which versions it applies to, and then also the differences between when we do version updates for operators, what the differences between those are, so that implementers can very quickly update their implementation according to the ONNX spec.
That is super helpful because I think many people that have converted models to ONNX and have set to different opsets, finding out which is the most recent one that will support the operators in your model can sometimes be difficult to figure out. So now this is amazing. You can jump right in here and figure out which opset is best. Cool. So can you show us where we would find some useful tutorials within this documentation?
Yeah, absolutely. So in the intro section, you can see there's tutorials here, and all of the major concepts within ONNX. So input, outputs, nodes, how to serialize, the metadata that you can put into an ONNX model, the list of available operators and the domains, etc. So it really goes into a deep dive into all of the ONNX concepts, and these tutorials should help you bootstrap your knowledge of ONNX.
That's great. These look super useful, and like it is going to be a great support to the community. So thank you so much.
You're welcome.
Okay, next up, we are going to be looking at the operator updates that were part of this ONNX release. Welcome. Why don't you introduce yourself and tell us a little about what you worked on?
Oh, yes, thank you very much. And my name is Liqun, and I have been start working on ONNX since the beginning of ONNX, and I've been working on ONNX converters and and operators for different update. And also recently, I have been working as the chair of architect and infrastructure, and we are responsible for each ONNX releases, and also how the CI pipeline is running, and we are responsible to keep ONNX in a healthy state and to maintain the release in a good pace. Basically, that's what I'm responsible for, and I'm glad to be here to introduce any new features we will have in the current release.
Thank you so much. And I also like to point out that we're twinning. Great. So why don't we talk about the operators that you worked on for this?
Yes, for this release, we have many operators update. On one side, we want to keep the change minimum to any operator update, or we want to avoid introduce new operators just because we want to keep ONNX as a standard to be able to support all runtime type of runtimes and anytime. Different types of frameworks. And however, we do also want to make our operators, to be as much as compatible with other platforms. For example, here we have Reside and Pride. We introduce some changes so that it is more compatible with, for example, PyTorch. And that's one reason we have introduced some, minimal but needed updated to those existing operators. And on the other side, we have also introduced changes to, for example, the optional hash element and offset gate element feature. That is the operator we want to use to support us to introduce to make things easy to convert some premier ops to function ops. And this activity is much needed in order to keep our ONNX premier op to a minimal in order to support existing and new runtimes without blocking, ONNX model conversion. Yeah, that's our operator update.
Great. So it's nice to see that we are continuing to work on supporting more model architectures by adding operations and updating the existing ones. So I think you have a demo to show us, right, on some of the new ones that were added.
Oh yes, I do have to really excited to introduce a new feature of operator function body management. And this is, since object version 1.13, the operator function body can be managed based on offset version of schema. Previous release, a optional option operator we can have one function body for a function operator, and with as ONNX offset involves a function body that is valid for the previous offset version might become invalid due to changes to operators used in the function body. I like to take mean variance normalization, for example. We also have a single function body in which reduce mean is used. And for offset version before 18, reduce mean takes access as an attribute. And since offset version 18, reduce mean takes access as an input. Because of this, the original function body used to define the function for reduce mean for mean variance normalization is no longer valid for offset version since 18. And with this new operator function body management, our schema allows multiple function bodies being specified for an operator. Here, we are able to add additional function bodies specifically for offset version since 18. And for runtime to load a model that contains mean variance normalization operator, the runtime can choose to inline the operator based on the model's offset import version. For a model with offset import version less than 18, the first function body will be used. And for models with offset version, import version equal or higher than 18, the second function body will be used. As you can see with this function body management feature, it truly enables flexible and reliable use of ONNX operator, function operator. Right? And this is a much needed feature, but because before we do not have a long history yet, with the changes of our operators, then we haven't seen this problem.
Okay. So it really helps kind of with like backwards compatibility, right? To allow people to use the new features, but also not make a breaking change.
Right.
Okay.
So that's, we think this will make function operators more reliable and flexible. Yes.
Awesome. Thanks for that great explanation of this new feature. It sounds like it's going to be very important for our users. What else did you work on this release?
Oh, yes. In this release, they have converted many primary ops to function ops. As you can see from here, there are many ops has been changed to function ops since offset version 18. And this is our continuous effort to reduce ONNX primary ops to a minimum in order to support existing and new runtimes without breaking ONNX version converter.
So you said that there's a primitive op and a function op. Can you tell me what the difference of that is?
Oh, yes, sure. So primary op in this doc, if we go up, all those ops at the beginning, they are primary ops, meaning, you have to, at runtime, have to provide a execution kernel for those ops. For example, like we have a simple example, it will be add, right? The add op is so primitive we don't have to, and we cannot use a combination of many other ops to build the op, because this is just a single op. So the runtime have to provide a kernel to support those op. And the more primary op we have, the more difficult for a runtime to support an ONNX offset, because it has to provide many as primary ops as we have in the standard. And to solve this problem, we are trying to make many of those ops a function op. A function op means we define the behavior. In the spec, we define the behavior of those ops. And in the meantime, we also provide a function body for those ops. So for runtime, if it doesn't have a kernel to compute, to execute this op, it can choose to take the function body from this op and just embed this function body in its execution graph. So then it can naturally execute the model, without actual effort to support those function ops. So that is, a way for us to, to keep our function, our operator set as small as possible, but still, able to support all the neural network models available in the world. And at last, I would like to thank Schumacher from Intel Corporation for making this release available to the community. It is a great work, from him and from the Intel Corporation. Thank you.
Thank you. Yeah, thanks so much. Really great explanation on what's coming. And yeah, I know a lot of people put a lot of great work into making ONNX work well for the community. So we thank you for being here and for all the great work that you do.
Oh, thank you. I'm happy to do this. Thank you.